Welcome to the session, guys. Based on our previous session, I thought we would go through just as a basic first stab, and we can change halfway through if we want to, how one might go about creating a basic finite element model, some of the key vocabulary, and some of the key ways of doing that using the BOM. And we're going to do that from Grasshopper because that's pretty low bar to entry. I think a lot of you are familiar with Grasshopper. Keep in mind that because the BOM is agnostic, you could theoretically do this from Excel, and you definitely could do this from Dynamo as well. But most people right now are using Grasshopper because it's just a lower bar to entry. So that's what we'll do. As part of this, we're going to go, strictly speaking, from scratch here. I've just put these up as sort of headers. And if at any time you guys have questions, obviously I have no visual feedback, so I can't see if you're confused or falling behind or whatever. So please just say, hey, whoa, what's up? And then we'll stop. Okay? So first thing we're going to want to do is we're going to probably want to create an adapter, because BOM does not have anything in it that's a finite element package. So if we want to create a finite element model, we're going to create an adapter. In Grasshopper, it will look like this. You'll have a BOM, BHoM tab, and then you'll see the three legs of the BOM appear: adapter, engine, OM. And that's the common thread of the BOM all the way through the three legs of the BOM. And we're talking about an adapter because we're talking about sending stuff eventually to a software. So I'm going to say create adapter, drop that down. I'm going to right click and look at the whole bevy of options that are at our disposal here. And I'm going to create an ETABs 2017 adapter. Right, so we just go through this filing, and we arrive at there's only one option for ETABs 2017, so we click that. Now I'm going to close ETABs 2017. I've been sitting on top of it because we have a license shortage in Hong Kong. So now I have to do this next part real quick so no one takes it from me. Software issues, can't wait for those to be gone. So we're going to close that, and I'm going to quickly come over here, and this guy just needs to be activated. So I'm going to give him a toggle. Now I'll plug that in, and welcome to the 20th century or 21st century version of double-clicking effectively the ETABs icon that you're normally used to. So you're used to ETABs 2017, and you click here. That's the computational equivalent in the 21st century. So we're well on our way. It takes a minute or so for ETABs to boot up because, why improve on things? And there we go. So ETABs just opened up from the Grasshopper canvas using the adapter. So again, you have to think of, at this point, what I normally do, and this is a great habit, is in Grasshopper, you got to get used to double-clicking the canvas and typing data. Data buckets are your best friend for keeping things clean. Kaylee was on me earlier about this script at a zoomed-out level. Guess where I started to run out of time in this script? Probably not here. Right? Up till here, everything was good, and then crunch time came, and it was just like, okay, we'll clean it up later. So data buckets are these things, and they really just allow for you to keep the script clean. They don't do anything other than contain information, and really the biggest information they contain here is, we're going to label this as FEA adapter, not ETABs adapter. If you didn't understand all these words about adapter and engine and OM, at least now you know a third of what's going on there and the practice that goes with it. Now, we haven't used it yet, but you could obviously see here there's a file path that we didn't use, but that should be fairly straightforward what that would be. And for something like ETABs, sometimes you need to have a file, because when it runs and you execute it, it needs to save all the temporary files to that directory. So. But that's step number one. So we've just instantiated a software. And our ultimate goal is to create some jazz and push some stuff over to that software. So let's start with the easy stuff. We know that in our future here is a push, so let's just get that out of the way. Push is sending stuff to an adapter. So it asks first thing first, it says, give me an adapter. We've just created an adapter, and when you see this script, what you should be thinking is I'm clicking, like right here, right now, I have ETABs. It's under my cursor, and I'm going to put that right in there, and now I've set that up. Next thing is objects that it wants, and the rest of this you normally don't need. So really, we need to create some objects, and then we need to activate this, and we'll send something to ETABs. Right? So I'm going to go ahead and turn that wire off because I don't like it crossing my screen. I'm crazy like that. And object creation. Okay, I'm going to teach you 2 vocabulary words that are just kind of one of those things you just got to know, bar and panel. So those 2 words are very important because that's BOM lingo, and what their equivalent are in first principles finite element is this is a 1D element, and this is a 2D element from first principles. I think CSI products usually call this a shell if it's fully rigidly elastic, and this one's usually called a frame. Again, computation really is about speaking different languages, literally sometimes in English. So these 2 are the main words. And we know now that we're talking about creating objects in the BOM. So you got adapter, that's probably not what we want to mess about in. Engine, well, that's doing stuff to objects, so we don't have objects yet, so we wouldn't mess around in there. And then there's OM up here, which is where we have objects, so we're getting closer. And create object is probably what we want to do. It's literally what it says on the scribble, which place that down. Now, here's a very important lesson about how to find, there's 2 different ways to find what we want. First of all, you have to know, roughly speaking, some sort of idea of what you want, right? So let's say I didn't tell you about this jazz, right? So you could come in here, you could right-click this guy, you go select an item, you go structures, because you're like, I'm a structural engineer, there's got to be something in here. And then you're going to go, oh boy, now it's starting to get a little bit more difficult. What the hell is a material fragment? But maybe you get lucky and you find elements, right? And then you say, oh, bar, that sounds like a familiar term. And then you get down to this screen here. So I've already taken a screenshot of this because I want to annotate it, and I can't do that while I'm in Rhino. So let me flip back over to that. You can see Bluebeam.
Yep.
Right. So again, it takes a little bit of experience and just getting used to the language and the structure of the BOM to know that this is the flow of where you want to end up, right? And obviously elements is the majority. I mean, you can see the words here over on this side. Those are the objects that we as structural engineers see all the time. Now here's where I've seen a lot of people stumble, because now all of a sudden I've found this thing called bar. If you've never got the trick that told you bar is a one-dimensional element, you still might be on the ropes as far as am I even in the right place. But even if you knew that, you'd be sitting here and going 1, 2, 3, 4, and you're seeing words like I section property. What the hell is an I section property? A bar, FEA type, all these words, and even on some of them, it's like 4 more inputs. What's that mean? So let's go over that real quick so that you can. Again, this happens on all of the different components. You have to be able to help yourself. Now, this is the underlying principle here, is that what you're actually seeing are the different functions which will create a bar for you. Now, a bar can be created in many different ways, so that's why we have multiple different functions. And what's being shown here is, you guys know the old f of x notation, right? That's what's going on here. This is the f of x. And what it's saying is the input in this situation is a node. Now here's the deal. Each one is going to say 2 things. So let me just zoom in ultra tight here. Let's just break this all the way down. So it says this one's f of x, y, z, yeah? Because you guys can probably see there's commas here, yeah? So why does it say node, start node? Because what it's saying first is the type. So this is of type node. And sorry guys, I don't have my doodle pad. So that's the type of the object right here. And this is the name of the property, right? So in this situation, if I look over to the right here, this guy's named double. Double's fancy computer speak for a number. And then this one's orientation angle. So this is sort of like the ones, you know, we say which way is the section going on the one-dimensional element? How is it oriented, basically? And then the thing is these names, when they're not double, which is a number, or string, which is a piece of text, what that actually implies is this is another object itself. So it's a node object, a BOM node object. Whenever you see, and one last trick here is whenever you see I, that's fancy computer speak for any type of section property. So I anything, I curve, I section property, I whatever. There's no other examples on the screen. That just means any type. I think a lot of people can get a little bit daunted right away because there's a lot of unknowns here right off the bat. First of all, what path should I be on? Second of all, what are all these different things? Third of all, what does this actually mean on a very local level, I section property, let alone why does it say I section property space section property? Now you know that. That's the most important thing because that will be a ubiquitous first principles thing that follows you all the way through your career in the BOM. I mean, usually I'm a guy who creates it by the second one, but there's no reason to that other than normally I know that I can quickly create a line. Section property is easy, right? Double orientation angle. You know, some of these other ones, for an example, I'd have to create 2 nodes, right, to be able to create this one. So it's just less work for me to do that. Doesn't really matter. It all depends on what you have at your disposal. And in this case, I would just say, let's go with the second one. Why not? I'll just pull out a couple of them, yeah? And I'm going to show you guys something now that I just found out because I just updated the BOM. And a lot of times when you're on live projects and you're using the BOM, you got to be careful about updating because it can screw up your script. So be careful with that. Not to say that, you know, you shouldn't be trying to update. Just note that it can be a problem on live projects. So, but then when you get to finally go to the front lines of the BOM, you get to have great surprises like the one I had getting ready for this one, which is the new feature in the BOM, which is lowering the bar even, no pun intended, lowering the bar even further for all the new people into the BOM, which is, this says, now we talked about it in the Grasshopper session, this says if I hover over it, I'm looking for a BHoM line. Now previously, you would have had to have gone either create object and go in here and start looking for BHoM object, which is under geometry, where's geometry, line, and then do the same jazz where you're like, oh, how do I want to define this line? Or you'd have to do Shift-Control-B and type in line, and then even more jazz comes up, and then you'd have to, you know, do even more mental gymnastics. Watch this. If you grab this guy and let go, now the only thing you need to know is that this little magic wand emoji means creating an object. This one with the little, so if I go up here, you guys can see it better. Let me just take a screenshot. So keep in mind that when you see, like, let's say this emoji next to one of those things that came up, what that really means is convert, right? If I see this one, right, it means compute. And if I see the little magic wand, right, that means create an object. And so that means that when I do this, pull this guy back, let it go, I know right away, in my mind, subconsciously, I don't even look at these guys because I know that they're not there to create objects. But the ones with the magic wand are ones that I know should be able to create objects. And then you just have to bank on the fact that you understand what a line is and say, well, how do I want to define a line? Do I want to define it by 2 points? Or do I want to find it by a point start in a vector direction? Yeah, it's all at your disposal. And I can repeat that now all the way back to bedrock. So this guy's asking for a point. I pull back. I get a point. And then if I pull back again, x is a number. So we don't have anything to replace the definition of a number. So to me, this is dope with a capital D, being able to do this so quickly now. Because if you're new to the BOM, this is kind of like, if anybody knows what IntelliSense is in script-based, text-based coding, this is basically IntelliSense for scripting. And it makes it such that you just have to basically play by the rules and go backwards and fill in the blanks here. Right, so property, I mean, now at this point I've told you what this is. This is a 1D element, so we're kind of familiar as structural engineers that the property, what that is, we can probably see it in our heads as something that is, you know, sort of looks like this physically, or like this, right? Or like a CHS or something like that, right? That's a horrible CHS, but you get the point. So if I pull back on this guy, I see that there's a lot of things that come up. The emoji tells me these are all exclusively things that create sections. I'll show you a little trick, because let's say, for instance, you don't necessarily want to go in here and create it from scratch. Up here in Create Data, OM, Create Data, drop that down, right-click, select an item, and we can go to, let's say, UK Steel Properties and make this a CHS. Now, if I pull out a panel here, what is that really? What's flowing through this vein right here? It's not just a piece of text that says CHS 60 times 2.9. It's actually an object that has its own hierarchy, which I think you guys have already heard of this week about exploding. If I explode this, there's a lot of jazz going on inside there. Now, yes, sure, if I go and I look at name, it exposes for me that piece of text, but there's a lot more going on inside of this. A lot of this should look familiar. Plastic modulus, elastic modulus, area, all that different jazz. And you might say, where's that picture of what it actually looks like? And that's actually embedded further within this object, explode section profile. And again, I just happen to know this because I use it all the time. You'll get it with experience. But now if I zoom in on that, I can see that that's the section profile. And if I change this guy, he changes, right? But it's this nested hierarchy that you have to get used to. And I know we talked about this before in the Grasshopper session. Just being used to the idea that each one of these objects, whenever you see that notation of bh.om.whatever, what you're really seeing is it's an object, and inside of every object is a nested hierarchy. So in this case, what's coming out of here is that nested hierarchy that this guy's looking for, because he's asked for a BHoM structure, section properties, and any type of section property. So this is a BHoM structure, section properties, steel section. And if I put that in here, he stays gray, which means he must be working, because red is bad, orange is kind of bad, and gray is awesome. I'm joking. Doesn't mean that it's right. Any questions on that? And again, I can keep playing the game here, working backwards. Now in this case, orientation angle has a default value of 0. I'm happy with that in my life. Release, that should sound familiar to the structures guys. I'm going to give it a pin-pinned, let's do fixed release, because who knows what it's going to do with pin-pinned if it's truly pin-pinned and going to rotate about its own axis. That's not what we want. FEA type gives me this guy. So this is where you might be able to specify, is it a tension only, compression only, what degrees of freedom are we going to give this bad boy? And then name, normally you don't give it because we don't really need to give the bar a name. You could, but I normally don't. So, really when you see it as like this, right, you'll realize that this is actually, the same type of thing, line, property, but the normal is being asked for now. And we can already, just being from first principles, understand that that's probably just asking us for a vector that's normal to the center line. Now, we're not going to do that because, we're doing an example here, and that's, it's not the point, right? But if you did have that, we would do that. So congratulations. I'm just going to clean up this jazz. We've just created our first dummy object. I'm going to go ahead and put a data bucket out here. Call this bars, yeah? I'm going to push this guy over, no pun intended. And he goes into objects. Add that to group. And then we know that we've created a bar. And if we want to get fancy with it, let's go ahead and let's see what happens if we do like a series. and we've just created a bunch of bars, right? Let's do it the other way. Right, just so we can, obviously back here, we could play with this 10 ways to Tuesday, but at the end of the day, we just created a bunch of bars, right? Now, we said we want to get those over to ETABs, so let's see what happens here. If I pull out a toggle, we go back now, and we said this push component is got everything he needs, we just got to tell him fire away. So we're going to go ahead and turn this to true, plug him in, and let's see if I look stupid. Live demonstrations are always like that. Hey, how you doing? And if we extrude view in our friend ETABs, extrude frames, apply. The key is what you normally have to do first, no matter what, is right now if you're looking in Grasshopper, my model's in millimeters, right? So that's going to be a problem. Now I happen to accidentally put in here numbers that when you interpret them, those numbers are 7, 8, 9, 10. So they could be on the orders of meters. But make no mistake, if I came out here and I actually drew something thinking that I was drawing something 20 meters by 20 meters, right, or 2,000 by 2,000 or something, no matter what you do, BOM will interpret it as meters, newtons, pascals, right? So there's no gigapascals, there's no giga, mega, kilo. It's all straight up base units, and it's all SI. So guys, that's I would say for a structural engineer looking to get involved here, that's, you know, the 80% rules right there that'll get you going. Now, the deal is most of the time, you know, we got to get over this idea that, you know, we're going to be parametric designers and every single bar is going to be set out parametrically. We know that most times, you know, the column center line is dictated to us, and we're going to have to do that, you know, feed that in here as in some other way. So potentially, you know, this part of the script goes away, but either way, we're going to need to feed in lines, right? So I could just as easily have done something like this, where I create a whole bunch of lines out here in space, reference them into Grasshopper, and oh great, get to show you a first type of error. Your computational career is going to be filled with red components. It turns red more than it turns gray, let me tell you that. And this is a classic one. Cannot convert type bh.om.geometry.polyline to bh.om.geometry.line. And this is fundamentally tapping into, do you really understand what the computer sees right here and what he sees right here? Effectively right here. And what's going on right when you get in here. And the key here is this guy's asked for a BHoM geometry line. And what did you put in here is really a reference line length curve, which if you know Rhino speak and Grasshopper speak, it literally means it's just a pointer to the lines that I drew out here in Rhino, which are certainly not BHoM lines. So this is a conversion error. This guy's not clever enough to know that, dude, those are lines, right? So most of the time what I do is I kind of just change it, right? So this guy is a bucket. If I double click and I say line, this guy's a bucket that only contains lines. So now if I look at what's coming out of him, it says line. Now if I put that in here, it works. Now those of you who are inquisitive people and go, well, you just said about, you know, this, what are these things? So this is a reference to something that's in Rhino. This is now what? But it certainly isn't a BHoM line, is it? And you're right. So what this is, literally, is a reference to the lines that we see on the left. This is a conversion of those to a Grasshopper line. So it's a copy of it, basically, conversion of the type. And here, what's happening behind the scenes is there's an inbuilt function that can say, I know what you are. You're a Grasshopper line, and I can convert you to a BOM line. But it's obvious then, in this case, that there isn't the same functionality in the background for a curve, even though that curve is a line. These are the type of things that get on people's nerves when they're first getting started and get them discouraged, because they're not actually thinking about what is literally under my thumb at each stage here, whereas the computer, that's all he cares about. He cares about, I live to take in a line. Maybe with some exceptions, maybe I can get a bit clever for you if you get me in the rough ballpark of lines from other software, but believe me, there's a reason why when you pull this back, these come up, because these definitely I can accept. So we just sent over a bunch of jazz, and let's go ahead and set up a pool. Yeah. So double click pool. We copy this FEA adapter. Yeah. Keep that over here. It needs that. Now, here's where you can't just ignore the inputs, right? So, and pooling, you kind of need a toggle. So unfortunately, just be careful with this, but you need a toggle. Now, before I do hook that up, let's introduce ourselves to requests. Request is, you're saying, get me stuff from that model, but what do you want me to get? So normally, let's pull this back. Ooh, we don't have it here yet. So I'll tell you right now, another key vocabulary word to get you started. Filter request. That's your main man when it comes to requesting. So let's just see what that does. So if I do Shift Control B and I type in filter request, that's the cheat code, guys. Again, we're looking to create a filter request, and so we look at the emojis that have the little magic wand, and this is where it can get a little bit difficult because this one in particular doesn't pop up right at the top of the list. So if you're a guy like me, you know that you're looking for this one. Let me just take a screenshot and go to this guy. So this is one of those things where I think maybe it's not so user-friendly, but at the end of the day, it's not impossible to overcome. But this is the kind of command that if you have this one under your belt, it's the majority of the time that you're doing these things. When you first get started, that's what you'll be playing with. So filter request, and then the guy you want to be going after is this guy right here, the one that says type and string. Does everybody see that? So that one should be more prominent because it's used so often, but it's kind of buried down here. Again, we know we shouldn't be looking at these emoji guys because they are calculations and queries. We're looking for these emojis, and then it's just a question of, there's a trillion different ways to request information. So you can see in some of these category filter request, right? So in this situation, you'd probably only be asking for, I think that one's only going to work for sure. The one below him is only going to work for Revit, family filter request. That's a very specific name for a component. So that filter request, if you were using Revit and you were trying to grab jazz from Revit, that would be your main guy, right? But most of the time, pretty ubiquitously across all the different softwares, this component, filter request, is very useful, and it's for one main reason. So let's just pull them up. The reason, see now, even me, guys, I have to kind of struggle to find him. Because normally we like to say to software, could you please give me all the objects that you have of a certain type? And a type is just a type, right? It comes up with this little type emoji. In this case, we know two magic words. One of them is bar. And at this point, I type in bar, and there's a lot of things that come up, but the first one is BHoM elements bar. So now, what comes out the back here, if I pull out a panel, is a BHoM data filter request. So embedded in that is the question, Mr. Software, not ETABs, just any software, can you please give me all the bars that you have. So we're ready to rock and roll. We got our filter. We know the pool he lives to serve. He says, who do you want me to go to? What do you want me to get from them? And then, send me in guns a-blazing. And in this case, we're ready to go. So let's do it. Something comes up, but we do receive back 10 bars. And this brings us to another useful, remember so I just did my famous hover. And if you can't see that, then you go over here and you say we got stuff. Normally what I like to do is put out a data bucket that says bars. And then we had said in the Grasshopper lesson, another famous technique is to visualize those bars over in Rhino space. Let's not play mental gymnastics. Like, we don't describe bars as something that's just a list of text. We describe it as geometry. So when you said immediately, if I'm in green mode and I click something, I should be able to see it in Grasshopper. So what gives? Why can't I see this? And again, it goes back to understanding, well, what is it that you're literally clicking right here? Because I'll tell you one thing, the only things that you get previews for are geometrical components. And in this case, or containers filled with geometrical components. In this case, a bar is not a geometrical component. A bar contains things that inside of it inherently have geometry, right? So if you saw there, the second I opened this object up, all of a sudden I see some dots popping up here if I go back and forth. Everybody see that? And that's because I've actually exposed now this list of nodes. And again, if I explode those further, I can see again the position comes out of the woodwork. And that is actually something that I could probably bake if I put it into a point bucket, right? And then baked it. There they are. Yeah? So that's pooling 101, and again, I think the biggest lesson there is not anything other than this filter request. Now, there's a ton of different types of requests that you can find under, I normally don't do it this way, but I think it's under create request here, yeah? Under adapter, actually. And you can come in here and you could say, a lot of them are under data. DataViz has a specific few sets, but I mean, again, guys, it's really down to experience. And when you first start getting going, 90% of the time, for structural engineers, I can tell you, as long as you're not using Revit, if you're just doing the task that we're doing, filter request your main guy. There's some fancy filter requests that take in load cases. So if you were saying instead of the type of object that you wanted, so I'm going to make the type bar force. So this would be if we ran the analysis and we wanted to pool the bar forces. Let's just show how that would look real quick. So if I copy this jazz and I create this, oops. So this is now asking for bar forces. Obviously nothing's coming out because we haven't done any analysis. So let's just quickly, how can we do this easily? Let's make it not ridiculous, so let's repush, yeah. What's going on here? There we go. So those guys are all ready to rock and roll. I probably need to save this file because obviously ETABs being the way he is, he wants to actually be able to save. Hey, there you go. All right, so we know inherently, just based on the fact that it got a deformed shape, that we should be able to pool this again. So again, this is not a live updating system here. Maybe it is. So there we go. So you can see here that actually it still has all the old jazz inside of it, yeah? So I need to update this so that now I actually see the new stuff, yeah? And now if I look at this guy, he's still empty, right? So he has no forces, but if I double click and I click again, he has a bunch of bar forces, right? Which again, if I want to understand really what the hierarchy, again, an object is really just a hierarchy, I'll explode that dude just to get a feel for what he's given me. And in this case, as a structural engineer, I can see right away 6 degrees worth of freedom, an object ID, a result case, dead, 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 live, 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 time steps, positions. Like there's no surprises here. And it's not much different than, you know, if I came in here and I did Control T and started pulling out the results that are in here, right? There's no surprises. It's just in a different medium. So again, this is the powerful thing, because if you know that it's called bar force, that a bar's force, or in ETABs speak, we'd be saying a frame's forces, right? If you know that that's the equivalent, and we've already shown you the Rosetta Stone on GitHub, then at that point it really comes down to if that connection exists, and it's shown in the Rosetta Stone, it means you can just copy and paste this code and you're rocking and rolling. Because I kind of wanted to say, hey, listen, here's your guy in the bar 1D. So we've conquered half of these new terms that I said. So that's already, I'd say, we've conquered 70% of the mountain ahead of us, at least. So I kind of wanted to show you again how you would do it for the 2D element, because that's a fact of life, yeah, that happens. Especially considering that. Let's talk about this again. So again, the magic word is panel. Last time for the bar, we came up here, we dropped this down. I normally don't do that personally. I normally go Shift Control B, and I'll type the magic word panel. And again, I'm looking for, when I look at this, again, I hope this is really coming through, because again, it's teach a man to fish type of stuff. If I look at this, again, I'm really, in my mind, I'm automatically blanking out these guys, right? I'm automatically blanking out him and him and him, because I know that those are not what I want. This emoji encapsulates the verb that I want to do, which is I want to create a panel. And in this case, what I'm left with are these guys and these guys, right? And then it really comes down to, well, this one, environment, who cares about those ones, right? And then we get down to structures, and then we see there's 6 different options, right? So here's where you really got to go back to what we talked about before, about being careful about understanding, you know, that there's 2 things on display here. One is this, and one is this, yeah? And in this case, I never click on the first one because I'm lazy. Because this one says, give me a list of edges that are called external edges. But an edge is something that I normally don't have. I'd have to create it. What I normally have is, let's say, a piece of geometry. So I'd be looking for something that says, can I just give you like a rectangle that I sketch real quick? So, you know, I curve, outline. That sounds good because I have a curve, right? This edge business, I don't know what it is. So automatically in my mind, those go out the window. So I'm left with 2 now. And again, now I get rid of this one because this one says list of openings. And again, I'm like, I don't really have openings. And I know that when I see a word like this, it's not just, I can't project on that an opening is a curve or something like that. No, there's a reason it has a capital letter at the front of it. It's because it's a BOM object. And the proof's in the pudding, because if I go out here, I do Shift Control B, and I type opening, you know, I get objects that come up that need proper inputs to be able to create them. So you need to be careful on that. In this situation, if I type panel, we're down to that last one that takes in, basically, just by looking at it, 2 lists of curves, a surface property, and a name. Now, we all are structural engineers. We all know inherently that if we were in ETABs and we want to create a shell, we would need, that's the things that we'd need. We'd need things that define the outside, things that define openings, and things that give it a 3rd dimension thickness thing. So there's no surprises here. It just, the 80% of it is knowing the cheat code, and the last 80% of it is knowing how to sort of understand how to get this guy on the canvas. And then the last little bit is knowing how to fill it in, which we just found out today is child's play, because IntelliSense has come to the BOM. Okay, so let's flesh this out. Yeah, we go outline. We're working backwards here. Now in this case, what I'm going to do is I'm just going to sketch something, because I happen to know that if I, again, knowing a little bit about what I'm giving it here, I'm giving it a Rhino curve, and someone has, made that conversion for me. So that's always a good thing to try, but just know that you're trying it. Know that there's a conversion going on here. Again, openings-wise, it's asking for a curve now, so I could actually kind of give it a couple different curves here, see if it works. How you doing, right? And of course, this is like parametric in the sense that, I could probably afford to do that with it. Yeah? And the property now, what's the property? And this one's a great one. First thing that comes up, constant thickness, bada bing. And we just put in some numbers. Again, remembering that the thickness is in meters. So this is a 300 meter thick slab. The material needs to be filled in. I could go backwards from here and say, what's the material I need, right? So we could make a material. We could sit there and say, let's make up a concrete material. Better thing to do would be to go back to create data up here and go into materials. And you got all the concrete jazz in there. Again, we talked about this before, where this is actually not just a piece of text. There's actually, if I explode that, it's the opposite of this guy. You'll see the opposite. A little bit more. But basically somewhere in here, embedded in here, are all the different properties that would go into here. Yeah. Constant thickness, name, and type. And this is where we might get a little bit fancy here soon. Let's leave the type for now. It's giving you a thing. And let's go ahead and try. So here's our 2D shell. Going over to ETABs. Let's go ahead and create a new push so that we can push things separately. So we'll call this jazz panels. Yeah. Put the panels in there. Add that to the group. And then we push. And let's see, I didn't see any red come up. Did we get a panel? Oh, this thing was locked, so probably not going to work. Try again. Hey, how you doing? Right? And if we right-click him, he's working. Let's see here. Where's his thickness? Does anybody notice here that the section property didn't apply? Yeah. Does anybody know why that happened? Because look, it says it right here. It says, hey, there's a section property, right? And that's going on the panel, and the panel's obviously going over to ETABs. So where have the error's on the screen? What have I done wrong here? So number one, the name, obviously that software relies on a unique name for a unique thickness, right? So I've just put in a dummy name here, right? We could probably just put in this, right? Let's see what happens. So just because the computer says it doesn't turn red doesn't mean it's right. And now in this case, we see that 0.3 came up, right? But the other thing is someone else hit on is it could have been just as easily the type, because that's undefined before we put this in here. And then it really comes down to, what do all these things mean? In this case, I can tell you, you don't need that by default. Another one of you might say, what happens right now? This guy is, by definition, he's a shell, right? He has rigid elastic shear effects, 6 degrees of freedom going on. What do I do if I wanted it to be a diaphragm, right? How do I deal with it? How do I make it a diaphragm? In that case, diaphragm goes on here, and as you can see, this is these are the options that come up. Now I'm going to take a screenshot of this, print screen. Because again, if you're using ETABs, certainly you know about diaphragms because you know that, hey, if I'm doing a tall building, maybe that's what I want to use. And again, now we have to think about the emojis. So we don't care about types. We already know what that's about. And then really it comes down to, do we want to create a diaphragm? So BHoM elements diaphragm, right? Or in this case, I'll give you the answer. I have a panel. I'm seeing the inputs here, and I know that this emoji means convert. So this emoji right here means convert. So this one says set diaphragm. So in this case, I know that actually I'll just take this component right here, use that to change my panel into a diaphragm so it loses those degree of freedoms. So let's do it again, diaphragm. And what was that? That was now it's the first one that comes up. So he's asking for a panel. I'll give you a panel. And now he's asking for a diaphragm, which I can work backwards from now and say, let's create a diaphragm. And now I need to give that diaphragm a name. I'll just throw in dummy letters here. And he wants a diaphragm type. And in this case, these are the ETAB specific things. You guys know the difference between rigid and semi-rigid better than me. Now if I push this over, again, knowing that I have to kind of delete this because of the way we've set things up. Now let's see how he acts. I think the good news is there, guys, the only other thing I want to show you is how trivial it is to basically, and the reason we've done it this way is if I wanted to be a guy who, let's say, pushes it to robot instead, that's donezo at this point, right? Other than the fact that we have technically applied a very ETAB specific thing in the fact that we've used diaphragm there. Effectively, this short lesson for any structural engineer gets you into the space of creating finite element models via the BOM.